Okay, so if you have practiced the absolute value inequalities from the last section, then the interval notation and solving inequalities should be pretty easy for you at this point. I'm going to introduce something that's a little bit more complicated, but if you break it down to basic principles, it really isn't that difficult. First thing that you need to remember is that if you multiply a plus times a minus, you're going to get a minus. Or if you divide a plus and a minus, you get a minus. And anytime you have two minuses multiplying or dividing, you get a positive answer. So for these problems in 3.6, we don't care what the value of the answer is. We only care about the sign. Is it positive or negative? And if you can break down each problem and see it as whether it's plus or minus and ignore the actual numbers, it makes it a whole lot easier. And another thing is what you're going to learn in this section is so stinking valuable later on. When you get into a calculus class, you're going to be doing this for almost every single problem. You're going to take the whatever thing you end up with, you're going to find where it's exactly equal to 0, and then you're going to check in between those exact 0 places and see whether your value is positive or negative. For example, if I've got x minus 2, I find where it's exactly equal to 0, and then I'm going to take test values on either side of that, and I'm going to plug those test values in. So if I plug a 0 in here for x, I get -2. My answer was negative. If I plug in a number that's bigger than 2 in for this x, then that thing is positive. 5 minus 2 is a positive number. I don't care that it's a 3, I just care that it's positive. So I'm going to use a number line to keep track of things. I'm going to put the place where it's exactly equal to 0. These are called critical numbers. And I'm going to use test points on either side to plug in for my x values and show whether my blob is a negative out number or a positive number. And if we have more than one factor, we'll have to multiply those things out and use these principles of positives and negatives to get our final positive and negative, okay? So it'll make more sense once we start doing it. And remember, if the value of x is traveling along through, taking on all the real number values on a number line, when we're on one side of a critical and then we hit a place where it's exactly 0, my sign flips from either positive to negative or negative to positive. So as we're traveling along, every time we hit a 0, our sign will change. And that's huge because once we get used to this, we can kind of cheat the crap out of these things in a good way, the right way, cheating. We'll understand how the signs flip-flop, and we can not cheat. We can intuit. How's that? We can intuit what's going to happen. So here we go. So the first thing you need to do is find the values of x that make each factor in your problem exactly equal to 0. I'm going to call these my critical values or my crits. All right. Whether those values are in the numerator or the denominator, it doesn't matter. Even if the denominator, the places where the denominator are equal to 0, we can't include in our answer, but the sign will change when the denominator flips from minus to plus or plus to minus, okay? At these values where either the top or the bottom, any of the factors are exactly equal to 0, at these values, the sign of the entire expression will flip. It'll change, okay? And something silly here, and it may sound simplistic, but if you change the way you see greater than or less than, if there's 0 next to it, greater than 0, we're going to see that as positive. less than 0, we're going to see as negative, and it makes a huge difference in how we think about these problems. And we're going to be able to just zip, bang, boom, write down pluses and minuses when we see when we see greater than or less than, and it's all about positive and negative for these problems. Okay, looking at this right here, we've done these problems where we have equal to, and that's exactly where we have to start. Our first notice that greater than 0 means our positive value. The final answer will be the intervals that make this thing a positive answer, okay? But we have to figure out where it's exactly 0 first, just like we always have. So we're going to factor this thing. We're going to set each factor equal to 0 to get our critical values. Now, notice that this is not or equal to, it's simply greater than. So our final answer is not going to include the -4 or the +1. So your steps, look to see what your final answer will be. In this case, it's the pluses, the positives. Then you set your factors equal to 0, and you find your critical numbers. That's step 1. Step 2. Step 3 is to put it all on a number line. Do this every single time. You need to see what's going on. So I draw my number line, and I take the critical numbers and I put those on the number line. Now I know this is all jumbled up right here, but let's take it piece by piece. In the black, I have put my critical values on the number line. Notice that I didn't just put a little tick mark. I'm taking the entire -infinity to +infinity and splitting it up into intervals. I had 2 critical values, so I have the interval less than all of it, in between the 2 crits, and greater than the largest crit. So I have 3 intervals that go from -infinity to +infinity, and I'm going to take test values in each of these 3 intervals. Now I'm not going to plug my critical values into my problem. I know that they make it equal 0. I'm worried about outside my critical values in these intervals. Because I don't have equality, I have an inequality, okay? So I'm going to find these critical numbers, put them on the number line, and then I'm going to use these test values, okay? I'm going to take the test values. This is important. I don't care about the number that plugging in -10 gives me. I care about the sign that it gives me. So I'm always going to take my critical values and plug them in to the factors. It's all about the sign of the factors. So when I take a -10 and I replace this x with -10, -10 plus 4 is a negative number. See the in blue here? That's the first factor with -10 plugged in. Then I plug the -10 in for this one. -10 minus another one is also a negative. So when I plug in a -10, I get a minus times a minus. A minus times a minus gives me a plus. Okay? So for all of these x values, from -4 to -infinity, when I plug them in, I get a positive product. 2 minuses give me a plus, and that goes for any of the x values here. Notice that my problem, the only place where anything is going to happen is at these critical values. That means that from -4 to -infinity, all of my products are positive. Let's do it again. Let's take the test value that's between my 2 critical numbers. I'm going to plug a 0 in for each of these x values. When I plug a 0 in here, I get a plus. Plug a 0 in here, I get 0. -1 is a minus. So I have a plus times a minus. That gives me a negative answer. Okay? Now, some of you did this in high school and you learned to put true or false, but for those of us whose first language is English, we always relate positives with true and negatives with false, so don't do that. We'll go back and pick this up at the very end of the problem. For now, just show that this test value gives me positive answers. This test value is going to give me a plus times a minus, which is a minus. Take the last test value, plug it into each of these factors. I get a positive 10 plus 4 is plus, positive 10 minus 1 is a plus, 2 pluses multiply to be a plus. Okay, now that I have that final signs of each of my intervals, I'm going to go back to the original problem and see that I'm looking for the positives. My answer will be wherever I got a plus. So I circle my pluses, and my intervals will be wherever I circled those pluses. Look at the number line. This interval makes a true statement. So x goes from minus infinity to minus 4 on the number line, and it doesn't include because it's not or equal to. So there's the first interval. The minus does not give me a true statement because I'm looking for positives. The plus here says that all of these x values from 1 to infinity give me a true statement. So my second interval is from 1 to infinity, and it doesn't include the endpoint. Okay, so what were my steps? I'm going to see whether I need a plus or a minus for the final answer. I'm going to factor it, set the factors equal to 0 to get my critical numbers. Then I'm going to put my critical numbers on the number line every time. And then I'm going to pick test values that are in each of those intervals that I created. I'm not going to put just a little tick mark. I'm going to make sure that I see that I'm splitting the real numbers up into intervals. So once I found my test values, I'm going to plug the test values into the factored form of my original inequality to see if the factors give me pluses or minuses. Then I multiply out those factors to get the final pluses and minuses. I don't care about the value that we get. I'm only looking for the sign, which makes these problems really easy if you follow the steps. So once I've multiplied out what I got with my test values, the pluses and minuses, to get my final positives and negatives, I go back to the beginning and see that I need positive numbers. Circle the pluses, write down those intervals in interval notation, and that's how you work these problems. So now we have an example that's using division. Division is the same as multiplication when you're talking about pluses and minuses. Two minuses give me a plus. Opposite signs give me negatives. So first thing we're going to do is check what we're looking for. We're looking for less than 0, which means my final answer is going to be the negatives. Okay? Then I'm going to set each of those guys equal to 0 to get my critical values. The top gives me a 3, the bottom gives me a -5. So here's my critical numbers. I'm going to put my critical numbers on the number line, the -5. By the way, I know it's simple, but make sure you're putting these guys in order on the number line from minus infinity to plus infinity. Sometimes we are not paying attention or we get lazy and we put them out of order, and that screws everything up. So make sure that you're putting your critical numbers in the proper order from minus infinity to plus infinity. Make sure that you mark these guys off because you're splitting up the real numbers into separate intervals. Okay, take your test values in each of these intervals. Over here, this from -5 to negative infinity, nothing's going to change. So I can take a great big negative number. I can use minus a bazillion even. When I plug in a minus big number on the top, I'm going to get a negative on the top. Minus big number on the bottom, I get a negative answer, right? Negative 10 plus 5 is still a negative number, right? So a minus divided by a minus gives me a plus in that interval. So this fraction is going to be positive for all of these values of x. Okay, between minus 5 and plus 3, I plug in that test, pick any number that's between them. It doesn't have to be 0. I could use 2.9 if I wanted, or I could use negative 4.9. But why would I do that? I'm trying to keep this as easy as possible. And any value between minus 5 and plus 3, I can use as a test value. I'm going to get the same answer because nothing happens here as far as the sign change goes except at the critical numbers. So I take a number between, plug 0 into the top, I get a negative answer. 0 in the bottom gives me a positive answer. A minus divided by a plus gives me a minus sign. Do the same thing for some value greater than 3. Positive bazillion is going to give me a plus over a plus, which gives me a final answer of positive. Now, once I get my pluses and minuses, I go back to the original. I'm looking for negative. So I circle the negative. That tells me this interval is the only place where my answer is, that where my expression up here, my inequality is true. So all of the values from minus 5 to plus 3 make this thing a negative and make this thing true. So my interval is minus 5 to plus 3. If you take that 10 and you plug it in here, you're going to get a negative number, a positive number, which makes that not true, right? That's the whole point of solving any problem, is to find the x values that make the original question true, okay? So notice that we're not including either of our endpoints because we don't have an or equal to. Something to keep in mind, if you have an or equal to, you include your endpoints, but you can't divide by 0. So you have to be really careful with division, okay? Well, I'll show you an example of that coming up soon. Okay, next example. Look at this big nasty. Factoring a cubic isn't as easy as factoring a square, but notice that we have a common factor of x in this problem. So when you factor it, you got to pull the x out first, and then this is easy to factor. So step 1, less than 0 is a negative, and notice that we have an or equal to. Okay, so we're going to include our endpoints in this answer. So I factored out the x, I was left with this quadratic trinomial. Factor this, the factors of 12 that add to be 7 are 3 and 4, both of them minuses. Once we get it factored, we set the factors equal to 0, and we get our critical values of x here. Write your number line, put your 0, your 3, and your 4 in order. Make sure you see that you're splitting the real numbers up into intervals. Now I take test values that are in between or on the outside. Notice between 3 and 4, I don't have any whole numbers, so I chose 3.5. I don't usually like writing mixed numbers, and I don't like writing decimals. I usually want you to use an improper fraction. But for this, we're just looking at whether we have a positive or a negative. And plugging in a fraction, if you have to calculate it, I know that that's ew, but using this right here just to get positive or negative, it's pretty dang easy. I'll show you. So we're going to take a great big negative, and I'm going to plug it into each of these 3 factors. I don't want to have to calculate the value. So always use the factored form because all you care about is the sign. So if I plug in a negative 10, I get a minus, and a minus. Negative 10 minus 3 is a negative number. Negative 10 minus 4 is a negative number. Negative 10 is a negative number. So I get minus, 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 which gives me a minus. Remember, 2 negatives cancel. You're left with the third. So we have a negative product. Plugging in the next test value, it could have been a 2, it could have been a 0.1, it could have been a 0.999, it could have been anything between 0 and 3. I chose a 1 because it's easy. Positive 1 gives me a plus. 1 minus 3 is a negative, 1 minus 4 is a negative. I get a plus minus minus. Let me point something out. We started out with 3 minuses. When we pass a critical value, one of those minuses became a plus. I passed through the value that made one of my factors 0, so that sign flipped. It always flips when you pass through a 0. One of the factors changed from minus to plus, which meant the whole thing changed from minus to plus. Watch what happens when I pass through the 3. I have a plus minus minus. I pass through the 0, which makes my middle factor 0. That sign's going to flip because I passed through 0 on the number line. I went from minus to plus for that middle factor. Now I went from plus minus minus to plus plus minus. And now I only have one minus sign. The whole thing flipped. So notice all the way through here, when I started with a negative, because I had 3 minuses, every time I pass a critical, I flip my sign because only one factor flipped. That flipped the entire thing. When I pass through the last critical value, all 3 factors are positive. So that's one way that you can intuit, not cheat, intuit what's going to happen, because all of these factors are just to the first power. When you pass through 0, you flip from plus or minus, and because they're all multiplying, my final answer is going to flip. So that's one way you can check yourself, and you can predetermine what's going to happen. I still recommend that you check with your critical numbers, but it makes sense that you're going to get minus, plus, minus, plus. So once you get all of those things, you go back to the original. Less than 0 was negative. And notice that I have an or equal to. So in this one, I'm going to box in my endpoints. I'm going to circle where it was negative because that's what makes it true. And I'm going from minus infinity to 0. I never equal infinity. I box in the 0. The next interval is from 3 to 4, and I can equal my endpoints because I said it could equal 0 exactly, and that's how you do this problem. Now, some things that are a little bit more complicated. So for this problem, we have a fraction, and we have a greater than or equal to. If you're dividing, you can't divide by 0, so you have to be very careful with your interval notation for this problem. Everything else is the same. I'm looking for positive or equal to. All right? Now, again, you got to be super careful because you can't divide by 0, and you represent that fact with your interval notation. All right, step 1, we got to factor everything. So on the top, we have a difference of squares. On the bottom, I can pull out a common factor of x greater than or equal to my critical values. Set each of those factors equal to 0. I get a plus or minus 1 from the top, a 0 from the x on the bottom, and a 3. All right, number line. Make sure you put these guys in order. I have a minus 1, a 0, a plus 1, and a 3. Take your test values. I'm going to say minus a bazillion, minus a half, plus a half. Remember, we don't care about the value when we plug in these fractions. We only care about the sign. So that makes it much, much easier.
and a positive big number. Okay, start here. When I plug in the minus 10, I get a negative and a negative and a negative and a negative. 1, 2, 3, 4 minus. Remember, 2 minus signs cancel, so everybody is left as positive. All right, plugging in the negative 1/2. It's easier than it seems. Let me pick up a red here. Okay, so when I plug a minus 1/2 and I add 1, I'm now positive. So this factor flipped its sign and gave me a plus. Minus 1/2 minus 1 more, minus 1/2 by itself, minus 1/2 take away 3 more. 3 minuses make a minus. All right, next factor. When I plug in the positive 1/2, hold the phone. When I plug in a positive 1/2, that's a plus. Positive 1/2 minus 1 whole is negative. But now on the bottom, positive 1/2 is a plus. 1/2 take away 3 is still negative. So now you see that the sign of one of my factors flipped. Now I have 2 minuses, which gives me an overall plus. Now we move to the 2. 2 plus 1 is plus. 2 minus 1 is now a plus. See how that one thing flipped? Plug in the 2 here. Positive 2 is positive. Positive 2 take away 3 is still negative. 1 minus sign makes that whole thing negative. Now when I plug in a great big positive number, number 10, I have 4 pluses. 10 minus 3 becomes a plus. Everybody's positive. Boom. Now, go back to the original question. I'm looking for positives. Greater than 0 is positive. And then in my interval notation, I'll box in the numbers that make the top equal 0, but I cannot equal the numbers that make the bottom 0. So I have to be very careful, all right? So I'm looking for positive. I'm going to go back up here, circle the ones that make it a true statement, and those are the intervals that are in my answer. So I'm going to go in this first interval, I go from minus infinity to minus 1. I can never equal infinity. Can I equal minus 1? Well, negative 1 makes the tops equal to 0, and that says or equal to, so yes, I box in the 1. The next interval starts at 0, ends at 1. Notice that 0 would make the bottom equal 0, so I can't include that, but the 1 is on the top, so I can be 0 over a number because that equals 0. The next interval starts at 3 and goes all the way to positive infinity. The 3 makes the bottom 0. I cannot include that, and I can never equal infinity. All right, guys, so the or equal to is shown in your interval notation, but you got to make sure that you don't divide by 0.
Okay, let's see. We are looking for negative or equal to. All right. Now, when we get to where we're doing our interval notation and our answer, we have to watch this guy because we can't divide by 0, right? So the top can be exactly equal to 0, which makes the whole thing equal 0, but I can't divide by 0. So when I'm doing my interval notation, I have to make sure that I include the endpoints from the numerator, but not from the denominator, okay? And this can get a little bit complicated because I've got some serious factoring issues going on. So the first thing I'm going to do is factor the top and the bottom. Notice on the top that I can factor out an x squared first, which leaves me with x squared minus 4. which is itself factorable. So the factored form of my problem is going to be x squared, x plus 2, x minus 2, and the bottom is going to be x times x. Lots of factors here. I got a 1 and a 4, and the 4 is a plus and the 1 is a minus because I wanted the factors of 4 that subtract to be positive 3, okay? And that is less than or equal to 0 or negative or equal to 0. So I find my critical values. I get x equals. Now, this guy right here gives me x equals 0. Notice that it's there twice. So I'm going to note that to myself. It's multiplicity 2, which means there's special behavior at this critical value. Normally, when you pass through 0 on the number line, you change your sign. But this guy is squared, so he's going to be positive on either side. The other guys will be changing when we pass through their zeros, but this guy is going to equal 0 and then turn right around and go back positive. So it's just going to, it's very special behavior. We have to check both sides of that factor carefully. The rest of my critical values, on the top I get a minus 2 and a plus 2. On the bottom I get positive 1 and negative 4. Now the next step, I don't mean to be talking down. It's really easy to get these things out of order because there's so many of them. I have a 0, I have a minus 2, a plus 1, a plus 2, a minus 4. Make sure that you get all of those zeros and that you write them down in order. This is the second time I've done this video because I got mine out of order, so I know I'm preaching to you now because I made the same mistakes. Critical values in between. Minus 4 to minus infinity, right? So I'm going to choose a big negative number. In between minus 4 and minus 2, I choose that. In between 0 and minus 2 is minus 1. From 0 to 1, I'm going to choose a half. Remember, we're plugging it in to get the sign. We don't care about the value. So using fractions is not a big deal. From 1 to 2, I'm going to use 1.5. And then from 2 to infinity, I choose a great big positive. All right, let's check things out. When I take the minus 10, I plug it in here. That guy is always going to be positive. I don't have to check him, okay? I only have to check the other guys. So when I plug in a minus 10, I get a negative and a negative on the top. So I have a minus times a minus. On the bottom, plugging in the negative 10, I get a negative number here and a negative number here. Negative 10 plus 4 is still a negative. So I have a minus times a minus. 4 minuses are going to be plus. See how this works? I didn't bother with the x squared because he's positive. He doesn't change anything. Okay? Next test value, negative 3, plugged into each of those factors is going to give me negative 3 plus 2. Watch this. Negative 3 minus 2 all over negative 3 minus 1. Watch, watch, watch. Negative 3 plus 4 becomes a positive. What happened? We had 4 minuses here, but notice that we passed through this critical value that made this 0 on the denominator. So when I went from less than that to greater than that, I went from a negative value to a positive value. One sign flips, and when you multiply those guys out, the whole thing flips when you pass through a 0, unless that 0 is squared, and we'll see when we get there. All right, so when you pass through a 0, if one factor flips, the whole thing flips. Notice that now we're passing through the -2, which makes this guy equal 0. That first factor is going to flip from a minus to a plus. Let's plug those things in and show it for sure. When I plug the -1 into this, I get a plus. I'm not writing that down. -1 add 2 is now a positive. -1 minus 2 is still negative. -1 minus 1 is negative. And -1 plus 4 is a plus. So we had one sign that flipped. Now I have two minuses, which mean the whole thing flips to be a plus. Every time you pass through a 0, your sign changes, except for this one. This is the critical value that made this factor equal 0, but it's squared, so it's going to be positive on both sides. Nothing else is going to change. Let's show that. Plug in a 1/2 into this. 1/2 plus 2 is a positive. 1/2 take away 2 is a negative. 1/2, positive 1/2, take away 1/2 is a negative value. See how the fractions are easy when you're just checking your signs. And 1/2 add 4 is a plus. Do you see that nothing changed in my signs here because I passed through a square? That means my final sign for this bit is still a plus. It didn't change when I passed through the squared factor. Now I'm going to pass through a 1, which is going to flip that sign right there. Everything else is going to stay the same. Let's check it out. Plugging in a 1/2. 1/2 add 2 is positive. 1/2 subtract 2 wholes is a negative. 1/2 subtract 1 gives me positive 1/2. 1/2 add 4 is a plus. Notice that only one of these signs changed. I'm left with one minus, which makes the whole thing a minus. Last piece, I have a 10 to plug in. When I plug in a 10, I get a positive, a positive, a positive, and a positive. Notice that we passed through the critical that made my last factor go from minus to plus. Everybody's going to be a plus in this zone, so my final thing is positive. Now go back to the original question. We were looking for less than 0, which is negative, or an equal to. I'm going to go through and circle all of my minuses, but we have something unique going on here. From -2 to +1, I got two positives, which doesn't work for this less than 0 bit, but what about the minus? That x equals 0 is going to be included in my answer. So this is a very special case that the 0 is going to make this a true statement just because plugging in a 0 is going to give me exactly equal to 0. So I have to include that in my interval notation. Now just looking at the number line, interval notation is where is the statement true? What values of x give me a true statement? I have negatives in this interval. So from -4 to -2, I have that interval that makes it a true statement. Now I have to figure out if I include the endpoints or not. Now, the -4 is a factor from the denominator. I can't divide by 0, so I can't include the -4. That's an open parenthesis. The -2 comes from this factor in the top. If I equal -2, I get 0 over some number. Well, that's exactly equal to 0. As long as I'm not dividing by 0, I'm cool, right? So the top can equal 0. 0 divided by a constant equals 0. So I can include the 2. Moving on, the next thing I come to on the number line, I had this guy right here. Now I have exactly equal to 0. So for the next thing, I can put x equals 0, but I'm trying to put my answer in interval notation, right? So if I'm in interval notation, my interval here, I know this is weird, it's going to start at 0 and stop at 0 and equal the ends. I will also accept x equals 0. You don't run into this situation very often. More often than not, you're going to have to exclude the 0 from interval notation. Okay? And I'll put a thought bubble at the bottom for that. Okay? My next interval, sorry about that, the next interval is from 1 to 2. So I'm going to write down my endpoints. I start at 1. I stop at 2. Can I equal the 1? Nope, it's in the denominator. So that's an open parenthesis. Can I equal the 2? That's in the numerator. Yes, I can. Box it in, and I have written my final answer. Okay, I said I would put a note in a thought bubble. If we had that thing if we had greater than or equal to 0, then we would have had, let's see, let me write this out, minus 4, minus 2, 0, 1, and 2. I had, let me write this in green here, I had plus, minus, plus, plus, because it didn't change at the 0, minus, plus. Notice that in this problem I have greater than, so I'm going to go through and circle all of my pluses. Greater than 0 is positive. Oh, I forgot to change something. I'm going to go back and change something. Note, let's say that I didn't exactly want greater than or equal to, I only wanted greater than. So now I can't equal 0, so I'm not going to include my endpoints. I'm just going to include those intervals there. So I'm going from minus infinity to minus 4. I'm not equaling the endpoints. Then I'm going to go, look at this next interval. It's positive from minus 2 to 1, except here where it's exactly equal to 0 and I can't equal 0. So my interval has to go from minus 2 to 0 and stop and start again at 0 to 1. And this is what I wanted to show you. You can use interval notation to exclude a value. I'm getting infinitely close to 0 here from the left-hand side, infinitely close to 0 from the right-hand side, but I don't equal it in the middle. So you see how you can use interval notation to show very specific things. All right, so try those problems. Here's your homework from 3.6. I know we're skipping ahead, but it's good to get all of the inequality stuff done all together. So good luck, and the next thing that you'll see posted will be the test review. Watch for that.